The night sky above California shimmered faintly as storm clouds drifted across the Pacific. Beneath them, a slender tower of steel and flame awaited ignition, the SpaceX Falcon 9 rocket, standing proud at Space Launch Complex 4E at Vandenberg Space Force Base. Atop it sat the Sentinel 6B satellite, a gleaming piece of international engineering, destined to watch over one of Earth's most pressing challenges, rising sea levels. This was not just another launch. It was the continuation of a decades-long mission to measure the heartbeat of our planet's oceans. It was Sunday night, local time, when the world's eyes turned to California. Scheduled for 9:21:42 p.m. Pacific Standard Time, or just past midnight for those on the East Coast, the launch would mark nearly 5 years to the day since Sentinel 6B's twin, Sentinel 6 Michael Freilich, soared into orbit from the very same pad. As countdown clocks ticked toward zero, anticipation built in control rooms filled with engineers from around the globe: NASA, the European Space Agency, NOAA, Eumetsat, CNES, and the European Commission, all united for a common cause that transcended borders and politics, understanding the oceans that sustain us all. Meteorologists from the U.S. Space Force's Space Launch Delta 30 had spent the day studying radar loops and satellite feeds. A parade of low-pressure systems had drenched the California coast, creating an unusually soggy weekend. California has been one of the wettest places in the United States this weekend, said First Lieutenant William Harbin, the launch weather officer. Even wetter than parts of the Midwest, which is really abnormal for Southern California. With a 60% chance of violating weather rules, the decision was close. If the weather didn't cooperate, they would delay until Monday when conditions were expected to improve. But for now, there was cautious optimism. The air was damp, the ground was slick, and yet the sense of purpose was unwavering. Inside the SpaceX Control Center, rows of monitors glowed with telemetry. Engineers confirmed that the Falcon 9's first stage, serial number B1097, was ready for its third flight. If successful, this mission would mark the 500th flight of a reused Falcon 9 booster, a staggering milestone in SpaceX's march towards sustainable, cost-efficient spaceflight. The booster had flown twice before, but tonight it would do something few rockets have achieved: launch, separate, and return to land just 1,400 feet from where it lifted off. For SpaceX, it was another opportunity to showcase precision, innovation, and reliability in equal measure. The payload it carried, Sentinel 6B, was no ordinary satellite. Built by Airbus Defence and Space in Germany, it was the product of years of planning and international cooperation. The Sentinel satellites are part of a billion-dollar mission to track sea level changes with unprecedented accuracy, extending a record of data that stretches back to the 1990s. Its twin, Sentinel 6 Michael Freilich, had already been orbiting Earth, mapping ocean heights and currents. Now, Sentinel 6B would join it, ensuring that this critical stream of information remains uninterrupted for years to come. As the countdown passed the 10-minute mark, the final preparations began. Liquid oxygen flowed into the rocket's tanks, chilling them to near cryogenic temperatures. The Falcon 9 hissed and groaned under the stress of the cold fuel. Engineers checked every system: engine pressures, avionics, telemetry links, ensuring that no error could jeopardize the mission. Outside, the skies cleared just enough for a launch window to open. In the control room, a calm voice announced, T-minus 60 seconds. At precisely 9:21:42 p.m. Pacific Standard Time, or just past midnight for those on the East Coast, the launch would mark nearly 5 years to the day since Sentinel 6B's twin, Sentinel 6 Michael Freilich, soared into orbit from the very same pad. At liftoff, the Falcon 9 rocket leaped from the launch pad and bolted through the sky. Within minutes, the Falcon 9 had pierced the upper atmosphere. 2 minutes and 35 seconds into flight, the engines shut down, main engine cutoff, or MECO. The first stage separated cleanly, flipping backward in the darkness to begin its return to Earth. The second stage ignited, its Merlin vacuum engine burning bright against the blackness of space. Telemetry confirmed a stable trajectory. Sentinel 6B continued its climb toward orbit, its fate now in the hands of physics and precision engineering. Meanwhile, the first stage executed its boost-back burn, realigning for its return to Vandenberg. As it descended, the thin atmosphere buffeted its carbon fiber grid fins. Then, in a blaze of controlled fury, the engines reignited for landing. A sonic boom rolled across the landscape as the booster touched down softly on its pad, upright, intact, and victorious. Applause erupted in mission control. Another successful recovery, another demonstration of how far spaceflight had come since the days of expendable rockets. 57 minutes after launch, the second stage completed its second burn and coasted to orbital altitude. The payload fairing split open, revealing Sentinel 6B to the void. Slowly, the satellite drifted free, sunlight glinting off its panels. Within moments, it deployed its solar arrays, unfolding like wings as it prepared to begin its mission. More applause, more relief, and a deep sense of pride shared by hundreds of scientists, engineers, and technicians who had worked for years to make this moment possible. From its circular orbit, 830 miles above the Earth, inclined at 66 degrees to the equator, Sentinel 6B will scan 90% of the world's oceans every 10 days. Its advanced radar altimeter can measure sea level heights to within an inch, penetrating clouds and atmospheric interference. This precision is vital, not just for science, but for society. The data collected helps ships navigate safely, aids in search and rescue operations, guides commercial fishing fleets, and supports flood prediction models used by governments and emergency planners worldwide. Karen St. Germain, NASA's Director of Earth Science, summed up the mission's importance. This information lets us monitor significant ocean features like currents, sea level, and wave height, and gives us a view into the inner workings of the ocean. These measurements form the basis for navigation, flood prediction, and the protection of coastal communities. Every byte of information sent back by Sentinel 6B is another step toward understanding and mitigating the consequences of a changing planet. Despite its significance of its mission, officials avoided direct references to climate change, reflecting political sensitivities in recent years. But the reality speaks for itself. Sea levels have risen by more than 3.4 millimeters annually over the past 30 years. For coastal cities like Miami, Jakarta, and Venice, that figure translates into flooded streets, displaced families, and billions of dollars in damages. Sentinel 6B's data will be crucial for developing models to predict where and when such flooding might occur, and how nations can adapt to protect their people and infrastructure. The Sentinel mission also continues a remarkable legacy of collaboration and consistency in ocean monitoring. From the TOPEX Poseidon mission in the 1990s to Jason 1, Jason 2, Jason 3, and now Sentinel 6, scientists have built nearly an unbroken 40-year record of global sea level data. This continuity allows researchers to detect long-term trends, identify anomalies, and better understand the complex dynamics of Earth's oceans and atmosphere. Sentinel 6B will carry this torch forward, ensuring that humanity's view of its oceans remains sharp and clear. Meanwhile, back on Earth, SpaceX celebrated another flawless execution. The Falcon 9's first stage, now resting on its landing pad, represented more than a successful launch. It symbolized how far reusable rocket technology had come. This was the 500th flight of a previously flown Falcon 9 booster, a staggering milestone in SpaceX's march towards sustainable, cost-efficient spaceflight. This milestone was not merely about flying boosters once more. It spoke to the grace and reliability Falcon 9 rockets now have during liftoff and return. Meanwhile, back on Earth, SpaceX celebrated another flawless execution. The Falcon 9's first stage, now resting on its landing pad, represented more than a successful launch. It symbolized how far reusable rocket technology had come. This was the 500th flight of a previously flown Falcon 9 booster, a milestone that once seemed impossible. Each recovery saves millions in costs, reduces waste, and moves us closer to a future where space travel is as routine as air travel. For the scientists watching from NASA's Jet Propulsion Laboratory and ESA's Operations Center in Darmstadt, the focus shifted quickly from launch success to mission activation. Sentinel 6B began transmitting telemetry, confirming that all systems were operational. Within hours, it would start its calibration phase, synchronizing with its twin, Sentinel 6 Michael Freilich, to ensure consistent and accurate data collection. Together, the two satellites would work in tandem for several months before Sentinel 6B fully took over the monitoring role. High above, the satellite drifted silently over continents and oceans, tracing the curvature of the Earth. It passed over